Okay, today we are going to be taking all the transformations we have discussed and describing them and trying to figure out which ones they are. So if I look at this first one, there are 3 flowers located on our page. It says Deanna drew the center flower C. So you might want to highlight that one because this is the original. She used some transformations to create 2 other flowers, A and B. Which transformations did she use? So to go from C to A, if I look here, the leaf is on the opposite side. That means she flipped it over. So that means that C to A is a reflection. C to B then, the leaf's on the same side, so she didn't flip it, but it did get bigger. So C to B is a dilation. And it's a dilation that is actually an enlargement because it got bigger. Okay, this next part is just filling out a table so we can make sure we understand the properties of all 4 of the transformations that we have discussed. Remember, a translation is what we consider kind of like a slide. So on a translation, does the length stay the same? Yes. The angles stay the same. Perpendicular lines stay the same. Parallel lines all stay the same. The shape is the same, and so is the size. A reflection then is what we consider a flip, and those are all true also for a reflection. The size, everything stays the same. The rotation is a turn, and the size and everything also still stays the same. The dilation, which is the enlargement or the reduction, is when this changes. The length might not stay the same. The angles still stay the same. Perpendicular and parallel lines still stay the same. The shape is the same. That flower looked the same, but the size was not the same. Okay, but there are 2 instances where the length and the size stays the same. The length and the size would stay the same for -1 and 1. These are the exceptions to the rules. Okay, our next example then, they are giving you 3 triangles and they want to know how is A mapped onto both triangle B and triangle C. So if I look and I just focus on A to B, I can tell that's an enlargement. So I automatically know that this is a dilation. There are 2 things you have to find if it is a dilation. The first is the center of dilation. So if I connect my points, remember you might want to extend them out in both directions, and you must use a ruler during this time. That crosses at the origin 0, 0. So it's a dilation with the center at 0, 0. The second thing you have to find is the scale factor. They are both on the same side of the center of dilation, so it's going to be positive. It's an enlargement, so I should expect it to be greater than 1. The original has a side length of 2, and the enlargement has a side length of 4. So my scale factor would be the image over the original, which is 2. So I could say A maps onto B with the dilation of the center at 0, 0 and a scale factor of 2. Okay, now I want to look, how does A map onto C? So I'm going to move these just so it makes it easier for me on here to show you. If I look at A and C, they're the same size and shape. So now I need to figure out how one maps onto the other. If I look, it looks like they just took their paper and spun it around to give you C. So that means it's a rotation. In order to figure out what type of rotation, I have to figure out the magnitude, which is the measure of the angle, and also what direction. So to figure out the angle, I connect an original point with the corresponding image point, and I measure this angle. that angle is 90 degrees. So the magnitude is 90 degrees, and I have to figure out the direction. We're moving this direction, which is counterclockwise. So it's 90 degrees counterclockwise. You must remember that that is the same as 270 degrees clockwise. So if someone put on here rotation 270 degrees clockwise, they are also correct. Okay, our next one we're looking at here gives us 4 triangles. The original there is located in red, it's ABC. And they want to know how it maps on to each of the following. Well, the first one, ABC to PQR, they're the same size, it was just slid over. So a slide is also known as a translation. You need to make sure you're using the correct vocabulary term. If you just put slide, I would count off. So it is a translation, and then you need to figure out how it moves. Well, B maps onto Q, so I'm going to see how that moves. I go over 1, 2, 3, 4 to the right, and 1, 2 up. So it is a translation where X adds 4 and Y adds 2. So this is the algebraic way to represent it. This is how you represent it verbally. Okay, in order to do our next one, ABC to LMN. This one flipped over, and it flipped over. A is equal distance, 1 from the x-axis, L is 1 from the x-axis. So a flip is known as a reflection. And you have to note what the line of reflection is. It's a reflection over the, and they're both equal distance from the x-axis this time. So it's over the x-axis. Remember, the x-axis is also known as y equals 0. So either one over the y equals 0 line or the x-axis would be correct. Our last one here goes from ABC to XYZ. You notice they turned it, so you have to figure out how they turned it. Remember, for a rotation, you have to figure out the magnitude or the measure of the angle, and then also the direction. So if I connect A to the origin to X, these would be equal distance, so I know that is the center of rotation because they have to be equal distance from the center of rotation. So rotation center is at 0, 0 once again. And now you have to figure out the measurement. This is 90 degrees counterclockwise. We talked about earlier that if someone put 270 degrees clockwise, they're also correct, because I could start at A and go 270 degrees this way and get to that exact same point. Our next one is the table to fill out so that we make sure we understand all 4 geometric transformations. Remember, a geometric transformation maps an original onto an image. The first one is a translation, and a translation is a slide which the x units to the left and right and the y units move up and down. A reflection then is also known as a flip, and in a reflection, it's in the line of reflection. A rotation, which is a turn, goes about the center of rotation by an angle of rotation in clockwise or counterclockwise direction. A dilation moves about the center of dilation by a scale factor. You might need to pause it to get that filled in on yours. We now have guided practice page 104, number 2. You can complete it on the following. And your assignment is extra practice 8.5.